Hello everyone, welcome to our chapter Principles of Inheritance and Variations. Before I am starting this chapter, I told you that this is a very important chapter. At that time it's a tough chapter. Now I finished the chapter. In this chapter mainly we studied Mendelism and Mendelian deviations and the extra some features of the Mendelian characters. Mendelian principles or Mendelism means Gregor John Mendel put forward three theories. Okay. Law of dominance, law of segregation. Law of segregation, otherwise known as law of purity of gametes. And the third law is law of independent assortment. Okay, so Gregor John Mendel conducted his experiments on pea plants. He took 7 years for his experiments, and at a time he took 14 different characters or 7 pairs of contrasting characters for his experiment. Okay, and he published a book. The name of the book is Experiments in Plant Hybridization. Experiments in Plant Hybridization. The book written by Gregor John Mendel. Okay, so we know that Mendelism having some deviations. The deviations means some of the plants and animals are not following the Mendelian inheritance or pattern. So example for that is incomplete dominance. In case of incomplete dominance, the ratio is forming is both the genotypic ratio and the phenotypic ratio are in the form 1:2:1. According to Mendel, the monohybrid always possesses phenotypically 3:1 and genotypically 1:2:1. But in case of incomplete dominance, that incomplete dominance are shown by Andrenium or Snapdragon, then 4 o'clock plant, otherwise Mirabilis jalapa. In these of plants, they were showing the same phenotypic and genotypic ratio, so it is a deviation from the Mendelism. And the next thing is the linkage. Okay, linkage means the genes are close together. So close together genes are, I have the tendency to transfer to the next generation as a closed one. So they were showing less recombination. So when the linkage is seen at that area, the less recombination will be possible. Next is codominance and multiple allelism. Codominance and multiple allelism are also the examples of the Mendelian's deviation, because in case of codominance, the parental character are not expressing. Both the parental character have the equal chance to express as that condition is codominance. But in case of multiple allelism, more than one allele define a character. For example, for this codominance and the codominance and multiple allelism, the best example is human blood group. Human blood group having 3 allele. Okay, so in this they produces 3 different type of sugars, IA, IB and I0, and 4 phenotype and 6 genotypes are seen in human blood group system. Clear it is. Then the epistatis means contribution of more than one non-allelic gene. Contribution of more than one non-allelic gene, that is known as epistatis. Fruit color in summer squash is an example for the dominant epistasis, and coat color in mouse is an example for the recessive epistasis. Epistasis means they were not follow the Mendel's dihybrid cross ratio. According to Mendel, the dihybrid cross ratio is phenotypic ratio is 9:3:3:1, and the genotypic ratio is 1:2:1, 2:4:2, 1:2:1. Okay, it indicates that the dominant character which are expressed more frequently than the recessive one. Okay, and then, but in case of epistasis and linkage, this condition is not possible. Then after the death of Mendel, 3 scientists again rediscovered Mendel's work. Okay, and they proposed a chromosomal theory of inheritance. And the 3 scientists are Hugo de Vries, Carl Correns and von Teschmark. Okay, they were supported by the investigator studies. Walter S. Sutton and Theodore Boveri also supported their work. They proposed chromosomal theory of inheritance. Okay, then the Thomas Hunt Morgan again proposes chromosomal theory of inheritance in a new basis of linkage and recombination. According to him, the genes are which are linked or inherited together as a single unit, because the genes are situated together or close together. The genes are situating. That's why they are inherited together as a single unit. So on that basis, basis, we classify the genes are into two categories: completely linked genes and non-completely linked genes, or incompletely linked genes. Okay, so the completely linked genes shows less or never shows the recombination, but incompletely linked genes shows recombination. Okay, then after these studies in 1891, Hanking is a cytologist. He find out sex determination mechanism. According to him, basically there are three types of sex determination: XX female and XY male, ZW female and ZZ male, XX female and XO male. Okay, so some in XX case females are homogametic, and XY case males are heterogametic. Okay, so the presence of the gametes determine whether the child is boy or girl. Okay, then in case of honeybee, the chromosomes are not describing the sex of the determining the sex of the organism. In this organism in honeybee, the number of gametes, it may be haploid or diploid, that determine the sex of the organism. If it is a diploid condition, the organism is female, and in a haploid condition, the organism is male. The next is pleiotropy. Pleiotropy means one gene may control several phenotypes. For example, of the pleiotropy is phenylketonuria. Phenylketonuria is a disease, PKU. For the conversion of phenylalanine into tyrosine, they require the enzyme phenylalanine hydroxylase. Okay, when mutation occurred, mainly point mutation, the chromosome number 12, the PKU, phenylketonuria hydroxylase, is not producing properly. It will lead to the disease phenylketonuria. Okay, just opposite of this pleiotropy, that is polygenic inheritance. That means multiple gene control. Multiple gene control is single effect. Our human skin color and heights are the example. Human skin color and height are the example for the polygenic inheritance or multiple gene inheritance. Clear? Then we discussed about mutation. Mutations are different type. Mutations are the sudden heritable change in the genotype of the organism. Mutations are two type: point mutation and the frame shift mutation. The point mutations occurred by deletion, duplication, translocation, etc. Okay, all this lead to the mutation. The substance which undergoes mutation are known as mutants, and substance which changes the cause mutations are known as mutagens. So typically two type of mutagens: chemical mutagens and the physical mutagens. Chemical mutagens, example EMS and MMS. EMS stand for ethyl methyl sulfonate, and MMS stand for methyl methane sulfonate. Okay, and chemical mutagens, example ionizing and non-ionizing radiations, means UV radiations. Okay, then we discuss pedigree analysis. In pedigree analysis, it helps to identify the inheritance pattern of a particular trait. So in pedigree, we are using different type of symbols, so it is very easy to study. So on the basis, we studied autosomal dominant features, autosomal recessive features, sex-linked dominant and sex-linked recessive feature. So genetic disorders means the disorders which are occur through the birth. That type of diseases are known as genetic disorders. Mainly the genetic disorders are in two categories: chromosomal disorders and the Mendelian disorders. Mendelian disorders means alternation or mutation in a single gene. Otherwise, we can call it as a single gene disorders. Okay, then the next disease is chromosomal disorders, a change in the chromosome number, and the next the genetic disorder is incompatibility of genes. For example, Rh incompatibility. Okay, so chromosomal disorders means the aneuploidy or euploidy, either the increase in chromosome number or decrease in the chromosome number. Otherwise, the haploid set of chromosome number will be getting increasing or decreasing. So on that basis, we study Down syndrome. Down syndrome is trisomy 21. Klinefelter syndrome trisomy 18, and the Patavo syndrome trisomy 15. Then I repeating, Klinefelter syndrome, not trisomy 18, this is trisomy X, trisomy of the sex chromosome. Okay, 44 chromosome plus XXY. Clear it is. Down syndrome, trisomy 21, Edwards syndrome, trisomy 18, Patavo syndrome, trisomy 15. In Klinefelter syndrome, trisomy of the X chromosome. Trisomy of the X chromosome. 44 44 plus XXY. Okay, in case of Turner syndrome, they are having only 45 chromosome, 44 plus X. So one chromosome is missing. So in case of Turner syndrome, it is a female but lacking the secondary sexual characters. But in case of Klinefelter syndrome, it male but showing some female characters. Okay, then we discuss different types of autosomal dominant disorders. Autosomal dominant disorders are mainly two types. Not mainly two types. According to NCERT, we are studying the two type of autosomal dominant disorders, that are Huntington's chorea and achondroplasia. And autosomal recessive disorders that we studied hemophilia, sickle cell anemia and the phenylketonuria. Sickle cell anemia and the phenyl PKU. Okay, then the X-linked recessive disease that we studied, that is hemophilia and the color blindness. X-linked diseases always transmitted from the father to child. So father to female child. Okay, so she is the carrier of the disease, and the mother will give the inheritor or the defective trait only to the son. So the son is always have the X-linked recessive traits. So this is about the chapter. Now I concluding my topic. I hope all you can understand this all the topics. So study well all this. Okay.